So far in chapters 1 through 8, we have established three different data structures. And those three different data structures are vectors, matrices, and arrays. Then in the previous two chapters, we have looked at both built-in functions and user-written functions, which can be useful for doing calculations or particular operations that may not exist generically in R. This chapter is called Utilities, and this is kind of a grab bag for various things that have not been covered yet and certainly are good to know at this point, and they're just generically referred to as utilities. First one that's worth hitting is known as history. History is a command that will allow you to see some of the commands you have done previously. So if I type in history here and give it no arguments, it will show up over here. This is in RStudio. Now in R, it'll show up here in the command window. But in RStudio, it will switch you from environment, which is this tab, over to the history tab. That's what history did here. And in fact, you could just as easily have not typed that in and just clicked on history. You can see these are all the previous commands that I have put into R in reverse order. So I'll go back to environment at this point. There is another group of commands which I put in here as options. And options can be used in several different manners. We did this earlier. You can give more digits, say 17 digits, if you'd like. When you do that, if you display a number like 1/3, for example, you will get it to 17 digits. You can see the round off has occurred out there in that 17th digit. Here's another one which I won't execute, but you can change the width of the screen. For example, if you want the width, and by width I'm thinking from this far left side all the way to the right side, however wide you want the screen to be, you could change it to 99 characters. Now I won't do that because the default is working here just fine, but that's something that you could do if you wanted to with options. Here's another example with options. If you don't like the prompt, right now the prompt is a greater than, but if you want it to be, for example, a double greater than, you can make it a double greater than, but make sure to leave a space because that will give you a space between the double greater than and the cursor. And from here on in, our prompt will be a double greater than. Another one is to change the continuation prompt. And the continuation prompt right now is a plus. If you want it to be something else, for example, if you want it to be more question mark, and again, always leave a space here, then that will be the new continuation prompt. So take a look. If I'm going to say 2 plus 3 divided by 7 minus, and then there's my continuation prompt more, 8 times 5. It'll do that calculation, -37, and return you to the prompt. So if you don't like the prompt, most people don't need to do this, but if you care to do that, that can be done. Now here is another thing you can do with options. There is a parameter called Sci Pen. And Sci Pen, you can see it tells us exactly what it is here in the pop-up. It's a penalty applied to deciding to print numeric values in fixed or in what is known as scientific notation. Now I'm going to do an extreme value of Sci Pen here. I'm going to go up to 999. And then I'm going to put in a very, very small number. And let me go this way. That right there would be a number that would ordinarily be displayed in scientific notation, But because we have set Sci Pen to a large number, it will try to print it out without using scientific notation. And once again, you can see the round off here. That's a real problem that occurs in R when things can't be stored exactly. Now here's another extreme. I'm going to do the up arrow, and this time set Sci Pen to negative 999. In this case, R will do everything it can to push things into scientific notation. So even if you have something like 123, which would normally be just displayed as 123, it will be pushed into scientific notation. So you've got the option there with Sci Pen. I'll return it to 0 here, and hopefully it'll act well in both cases. There's 123, and there it does go to scientific notation, as you would expect. So Sci Pen equals 0 kind of sits in the middle. The third topic in utilities is what I refer to as getting help. R is open source software, which means there is no company, there is no toll-free number that you can call. There are just users that have posted things out on the web, and a lot of internal help for R. And let me give you a quick example of some of that help. If I type in help SD, SD is the function that computes standard deviation, and I hit return, what will happen is over in this window right here, it will go to the Help tab. And here will be some information on standard deviation. First thing it does is it gives you the name of the function, and it says what package it's associated with, and it's associated with a package known as stats. And it tells you a little bit about it. So here's the standard deviation. There's a description about computing the standard deviation. There's an example of how it can be used, and it's got a second parameter which says, do you want to remove the not available objects? And there are the two arguments. Detail, this uses an n-1 in the denominator, the same way var does. And there's a little c also. And then there's a little example. What is the standard deviation of the vector 1, 2? And then they're going to square that at the end, so you'll get a sample variance. And one way of running that example is to just type example, SD. Sometimes all you need is an example to get you going. And there it will produce the example. So in the example, it's exactly what we see over here to the right. It is calculating the standard deviation of 1 and 2 and squaring it, and you get 0.5. Now, because we have 17 digits displayed, we get to see the round off. 0.5 is the answer, and there's just a little bit of round off there. So if we were to change our digits back to 7, let's just do that. The default options digits equals 7. And then if we were to go back and rerun this example of standard deviation, you would get 0.5 and you wouldn't see the round off there. If you need help on an operator, you have to put it in quotes. So for example, if you want help on the plus operator, you put it in quotes, and it will lump all of the arithmetic operators together. You can see them here, plus, unary, negative, plus, minus, times, divided by, exponentiation. You remember these two. There's modulo and there's integer divide. So that's how you get help on a particular arithmetic operator, for example. Now, if you do a double question mark, well, there's two ways of doing this. First of all, question mark SD will bring up the help page. That's just another, that's exactly the same command as typing help SD, just fewer keystrokes. But if you were to do a double question mark and then put in something like median, what would happen is it would go out to the site and it would look for every single help page that's available that has the word median in it. So you can see there's median absolute value, median value, two keys running median, etc. A lot of different medians that are out. So that's the meaning of a double question mark before an operator. I'm sorry, before a function. Last thing is to look a little bit here at floating point representations. Numbers are not stored exactly in R. So for example, we've seen this already where you were instead of getting the 0.5 here, you got round off at the end. I wanted to be a little more explicit with that. When you type in a third, you get 0.333333, 7 digits, but then you don't know what's happening beyond those that are being calculated. Here's a number which is 11/4, and that's 2 3/4. That is stored exactly, both in decimal, which you see is 2.75, but it's also stored exactly in binary as well. Here's a number, 2/5. Now you're going to see 0.4. That is calculated exactly in decimal, but behind the scenes in binary, 2/5 is not stored exactly. And here's an example of what can go wrong with when things are not stored exactly. Here are the numbers 1 through 14. And what I'm going to do is I'm going to take 2.5, which is stored exactly, and multiply that by each of those x values, multiplied by 0.4. And then after that, I'm going to subtract off x. So let's see what's happening here. 2.5 is the same as 5/2. 0.4 is the same as 2/5. 5/2 times 2/5 is 1. So x is just being multiplied by 1, and then x is being subtracted. So I expect a vector of 14 zeros to come out of this. And as you can see, even with the default number of digits being 7, we have some of them being 0, but others of them being, for example, 4 times 10 to the minus 16th and 1 times 10 to the minus 15th. Excuse me. So this is an example of round off and how it comes up. And it's something you have to look for in calculation, because sometimes when you're adding a bunch of numbers up several times over and over again, this little bit of roundup can creep up on you and cause problems in your final result. Well, that's it for utilities, and we will move on in the next section to topic 10, and that is complex variables.